Today, we came to Iracemapolis, here in the countryside of Sao Paulo, to the Starplast factory to show you how a helmet is made. Let's check it out. Gonna give you a spoiler. There's something really cool in this video. They have a helmet testing lab here where we can see if they're actually gonna protect your head. But let's leave that for the end. The conception and creation of the helmets is done right here. And there are two stages. The first is the physical part. The helmet needs to be strong, able to withstand impact. It has to be comfortable when you wear it, but it also needs to have a nice shape. The conception is done on the computer in 3D, and several tests can already be done at this stage. Some helmets are even 3D printed, so you can get a real sense of what the final product will look like. The second part is the design, the graphics. The same helmet shape can have several different designs. It depends on whether the helmet is for men, women, for those who like racing, mud riding, if it's for summer or winter. In the end, it's like sneakers. Everyone wants a stylish helmet. Just to give you an idea, every year, about 300 helmet designs are created. Shall we put it into practice? The first step is making the shell, the helmet's outer part. This will be done with ABS, a durable plastic also used in 3D printing. The plastic is heated to 482 degrees Fahrenheit and then injected at an extremely high pressure into a steel mold. It's one piece at a time, and the whole process takes about a minute. There are 21 helmet shell models and smaller parts, such as air intakes, all made with plastic injection. In the end, the robot sands the shell to remove the burrs, and the final finishing touch is done by hand. We need a robot like this one to make perfect balls at manual of the world, right? Strange to think about why it takes so much pressure to push the plastic inside the mold. They're getting some of this plastic at the right temperature so we can see its consistency. Yeah, it's extremely viscous. Do you think we can make a perfect ball? I think it'll take a while to cool down. This thing holds a lot of heat. Here, the shells will come out either black or in the natural color of ABS, which is this pearly shade. While one part of the factory is making the shells, on this side over here, the liners are produced, the part that will provide comfort. So there are several different stages. Here, for example, the robot cuts pieces of foam. It works more or less like our laser cutter, but they have a knife at the tip. This other machine is used to join the fabric with the foam. This is done by heating a plastic film that goes in the middle and acts as glue. Look how it comes out the other side. Another way to cut is with a press. They put a sharp mold which has exactly the shape of the foam, and the press pushes down on it. You can cut many layers at once. You know, I love discovering new tools, and today I found this one. It's used to make straight cuts, so it's a kind of small saw, and when I press a button, it starts spinning really fast, and on top of a ruler I have to move it to the other side. All these pieces are cut here, but they're sent to an external supplier for sewing. We'll meet them again soon. The painting will be done by a robot which can work on 2 helmets at the same time. The whole process only takes 12 seconds. Next, to dry quickly, These helmets go through a kind of oven with infrared lights. This ensures that the paint solvent evaporates quickly. On the other side, they come out all ready. The helmet designs are all made with stickers, with decals. It's a very thin plastic that goes into warm water. Then the paper backing releases some glue and the sticker is manually applied to the helmet. It's a task that requires a certain skill because the sticker is flat, but it has to be molded onto the spherical surface of the shell without leaving any creases. A layer of varnish is applied to keep the decal from coming off. The process is very similar to the painting done by a robot, but now the tunnel uses ultraviolet light, which speeds up the curing, the chemical reaction of the varnish. It's time for assembly, and one of the main parts is this one, made of expanded polystyrene, or EPS, which we also know as styrofoam. But hold on, it's not that soft stuff you take to the beach to keep your beer cold. This expanded polystyrene is much denser. Its function in the helmet is to absorb the impact, to make sure that when your head hits, it slows down gradually. I learned while recording this video that most helmets look the same size on the outside. What determines how it fits on your head is the expanded polystyrene. For those who have a small head, for example, this part will be thicker in order to fit better. Here at the factory, the project is by Starplast, but it's made elsewhere, it comes here ready. Another piece that's super important for safety is the chin strap. This thing that secures the helmet to your head. Not only does it have to be very strong, but also it's anchoring to the helmet, which is done with rivets, a piece that looks like a hollow nail, but then the machine will hammer it and it will open a hole where you attach it to the helmet. Here we can already see how the lining has come back from sewing, and you can notice that it's a complex job. It's practically a piece of clothing that has to be sewn because this is what's going to be in contact with the motorcyclist's head all day long. So it has to be very comfortable. There can't be any stitches that cause discomfort. And something very important that some people forget is that these parts are washable. So, hey, if you use this for about a month, it's a good idea to wash it and get rid of the dirt that builds up, right? The assembly process is also completely manual, including the visor mechanism, fabric cutting, air intake and exhaust, chin guard, neck trim, internal goggles, the visor, and the reflective stickers. A helmet can have more than 70 parts. Helmet ready? It's time for the most fun part, doing the quality tests. We're going to do 4 tests here, and the first one is the roll-off test, which is to see if the helmet stays on your head. But there's a detail: you have to be wearing the right size helmet. To know your helmet size, you need to measure the circumference of your head by wrapping a measuring tape around your forehead and over your ears. In my case, it's 23.2. Since helmets usually come in even numbers, we have to round up, so I'll use a size 23.6. This is when you find out you have a big head. Now the test is to drop a 2.2 pound weight. It will drop freely for 19.6 centimeters, and at the end it will pull this steel cable that's attached to the back of the helmet. This line here can't move more than 30 degrees, which means the helmet can move a little, but it can't come off your head, right? 3, 2, 1. It didn't come off the head. Asnella, I think it's a proof. The second test is for retention. Asnella, to see if the strap and the buckle down here, the rivets that hold it to the helmet, are holding up. Nala. So there's a fake head over there, and the helmet is already attached to it. Underneath, we have a 2.2 pound weight that's down here, that's already hanging from the strap. Here's another 2.2 pound weight. We'll drop it from 31 inches. When it lands, the total weight, combined with the rod and everything, is 50.7 pounds. All this weight will pull the strap down, and the helmet can't come off the head. 1, 2, 3, and... The third test is the visor puncture test. It's kept here at minus 68 degrees Fahrenheit. That means we're at the limit of how brittle it can get. It's going to be placed here on the helmet. A 6-pound weight will drop from around 4 feet, hitting this punch, this tip that will be touching the visor. The idea is that with all this impact, nothing reaches the motorcyclist's eye. Theoretically,
One, two, three, and it held up.
the visor was marked, but the eye should be fine. And the last test, which is also the coolest of all, is the impact absorptions test to see if the helmet is in fact protecting the head. So for that, what do we have here? A fake head. It not only has the size, but also the weight of a real human head, in this case about 10 pounds more or less. Inside, there's a sensor that will measure the impact on this head. And how does this simulation work? The helmet is in the freezer at minus 68 degrees, a good temperature to test its resistance, since that's about its limit. This test is also done at 122 degrees Fahrenheit and with a wet helmet. The helmet will be placed on this head, lifted about 8 feet and dropped in free fall. When it gets down here, the sensor will record the impact. Let's test it.
One, two, three, and
Watching is scary, but computer data shows the helmet passed the test. But I know that for you watching this at home, this is just a graph, just a number. Let's open it up and see what actually happened. Before I show you what the helmet looks like inside after the cut, I'm gonna show you these two helmets over here. These are from high-speed motorcycle accidents. These are from people who actually survived after falling off a motorcycle at high speed. What's interesting is that if you look at the helmet, it's basically intact, just a bit scratched. But if you put a little paint on it, it looks brand new again. But not really. Look at the helmet on the inside. Look at how the expanded polystyrene, the foam, is and how it's crushed. The plastic part, it's flexible. It also serves to absorb the impact, Masadu. But usually you can't see any cracks or any issues. And even if you look at the expanded polystyrene inside the helmet like this, you'll think everything is fine. But when we cut it, you can see it's really crushed. That means if you keep using the helmet after a fall, its main function, which is to absorb impact, isn't working properly anymore. It will never absorb impact the same way again. You have to throw it away. Honestly, if this is your first time seeing a test with a helmet cut in half, I think it's worth subscribing to Manual of the World and share it with that one friend who enjoys riding motorcycles. It's worth it, isn't it?
Surprised! This helmet is special. Let's see if you like it.
I love surprises. Let's see. This is so cool. It's so cool. Thank you. Thank you. Thanks. Super fancy, huh?